Welcome back to The Explainer, everyone. Today, we're diving deep into the past, and we're going to treat history just like a massive global jigsaw puzzle. If you've ever wondered how on earth we actually know what happened thousands of years ago, well, we're going to figure it out together today by mapping events, decoding clues, and building a complete picture.
Now, check out this foundational quote from E.H. Carr. It really sets the stakes for us. History is an unending dialogue between the present and the past. Basically, he's saying history isn't just some dusty list of dead kings. To fully understand the crazy world we live in today, we absolutely have to interrogate the past.
All right, here's our syllabus for today's interactive masterclass. We'll start with the vastness of Earth's timeline, learn to calculate time accurately, decipher physical clues, trace early settlements, and end by mapping out your very own history. Let's get into it. Module 1, Earth's Timeline versus Humanity. Let's look at the actual scale of the mystery we're investigating.
Okay, just look at the sheer scale of geological history compared to human history here. It's wild. The Earth formed roughly 4.54 billion years ago. Reptiles, they show up around 300 million years ago. But modern humans, Homo sapiens, we only emerge about 300,000 years ago. So human existence is just this tiny, tiny sliver right at the very end of the timeline. To put that into perspective, agriculture, which literally changed the whole shebang of how we live, only started 12,000 years ago.
Moving on to Module 2, Calculating Historical Time Accurately. To investigate that tiny sliver of human history, we need absolute precision.
You know, different cultures track time in some pretty fascinating ways. Take the Gregorian calendar, which most of us are familiar with. It tracks time forward into the Common Era, or CE, and backward into the Before Common Era, BCE. It's solar-based, got those leap years, you know the drill. But contrast that with the traditional Indian Panchang. This relies on complex astronomical data, tracking both the sun and the moon. It doesn't just tell you what day it is, it precisely predicts solar and lunar eclipses, exact sunrise times, and even gives weather predictions for the year. It goes to show that timekeeping can be as much a science of the skies as it is a record of days. Now, before we get to the actual math of mapping out historical events, let's establish our base units. A century is a period of 100 years, and a millennium is a period of 1,000 years. Whether we're moving forward into the Common Era or backward into the Before Common Era, we count these starting right from the year 1 CE. So, for example, the first millennium BCE stretches from the year 1 BCE all the way back to 1,000 BCE. All right, workshop time. Let's try a quick practice problem to map this out. Grab a pen if you want. Say the Buddha was born in 560 BCE. If we're currently in the year 2024 CE, exactly how many years ago was his birth? Any guesses? Let's figure out how to add those up. So step 1 is super straightforward. Just add the current CE year to the historical BCE year. 2024 plus 560 gives us 2584. Easy, right? But step 2 is the absolute crucial part. You have to subtract 1. Why? Because on the Gregorian calendar, there is no year 0. The timeline just jumps immediately from 1 BCE to 1 CE. So subtract 1 and we get our precise answer. The Buddha was born exactly 2,583 years ago. And we can literally count the years directly across a visual timeline to prove this rule. Start at 2 BCE. Jump to 1 BCE, that's 1 year. Jump to 1 CE, that's 2 years. Jump to 2 CE, that's 3 years. 2 plus 2 is 4, but minus our missing year 0 equals 3 actual years past. Boom. That's exactly how historical events are accurately mapped across that CE and BCE divide.
Okay, Module 3, Deciphering Clues and Sources. Now that we've got the timeline down, let's meet the specialized team that actually digs up the physical evidence.
Meet our historical detective squad. Everyone on this team plays a highly unique, absolutely essential role. Geologists, they study the physical features of the Earth, showing us exactly how soil and rock layers reveal specific timelines. Then, paleontologists take it a step further, searching those very layers for fossils of ancient plants and humans. Meanwhile, anthropologists are studying the actual societies and cultures of those humans. And of course, the archaeologists are the ones out there actively excavating the material remains, digging up the tools, pots, and buildings left behind. And a quick note. Working together, they cross-reference all these physical findings with ancient literary texts and written records to solve conflicting historical narratives. It's a total team effort. Now, there is a key visual difference in the evidence they're finding, and you've got to know this. A fossil is a biological impression, like a footprint or a leaf, that's been naturally preserved in soil or rock over millions of years. An artifact, on the other hand, is strictly man-made. These are your tools, pottery, ancient coins, or monuments crafted by human hands and excavated from ancient human habitations.
But, today, our detective toolkit is seriously upgraded. We're not just relying on digging anymore. Modern researchers use climate studies to reconstruct ancient weather patterns, chemical analysis to test exactly what a piece of excavated pottery was used for, and even modern genetics to trace biological traits passed down through generations. It's wild. We can look at genetic markers and ancient climate data to precisely verify exactly when and how these ancient settlements thrived.
Moving to Module 4, Tracing Early Human Settlements. Let's apply our new tools to a real-world scenario.
So, about 12,000 years ago, something monumental happened. The last ice age ended. The warming climate melted massive amounts of ice, swelling rivers and completely changing the planet's landscape. And this was the primary catalyst that forced our ancestors to adapt to a changing, warming world. The climate data tells us that living conditions actually improved, setting the stage for literally the biggest revolution in human history.
And we can trace this step-by-step transition. Step 1. Early humans were hunter-gatherers, living in temporary rock caves, just seeking basic shelter. Step 2. As the Ice Age ended, they moved near those swelling rivers for reliable water and highly fertile soil. Step 3. This is the big one. They began cultivating crops and domesticating animals like cattle. They finally settled down. And Step 4. Those small hamlets expanded into complex, connected villages featuring brand new technologies like pottery for storing grain. It's an absolutely incredible journey from wandering bands to settled agricultural communities.
Finally, Module 5, Mapping Your Own History. It's time to turn the magnifying glass on ourselves.
You can actually act as an investigative historian right at home by filling out a simple matrix like this to build your family tree. Track the relation, name, occupation, place of birth, and crucially, your source of information. Just like an archaeologist uses ancient coins or a paleontologist relies on fossils, you can use old documents, birth certificates, family diaries, and direct interviews with your relatives as your historical sources. Go ask your grandparents about their earliest memories.
Once you gather all those clues, plot them out on a visual timeline. You can start at 1900 CE, the beginning of the 20th century, and map out 3 generations visually. Mark the decade your grandparents were born, then your parents, leading all the way up to the present day in 2024 CE. It instantly contextualizes your family's personal story against the broader backdrop of modern history. Now, a great way to practice these detective skills is a local museum field trip. Here's a quick step-by-step guide. First, research the specific exhibits online before you go so you know exactly what era you're walking into. Second, observe the objects closely for clues about ancient tech and culture. Ask yourself, how is this actually made? Third, take detailed field notes. And fourth, synthesize your findings into a report highlighting any unexpected or fun discoveries. It's hands down the best way to practice observing artifacts in the wild.
As we wrap up today's explainer, I want to leave you with a final thought to ponder. We've seen how soil layers, old coins, and fossils tell the story of the past. If history is truly a jigsaw puzzle with missing pieces, what kinds of clues and sources are we leaving behind right now? Centuries from now, what pieces of the puzzle will future archaeologists dig up to tell your story? Keep investigating, keep questioning, and I'll see you in the next explainer.